So in the second part of the lecture, we're going to do a quick overview of water. Water is very unique. I remember I mentioned this before, and it nurtures all the life, all forms of life. And without water, the life is probably not possible. Recently, the scientists say there's probably life on Venus. So far, I did not see evidence of water, and that planet is very hot. But scientists are making new discoveries, so we're waiting to see what happens next. Remarkable physical properties. And water exists in 3 phases on Earth, right? In the same time, in different places though, it exists in liquid, most in liquid form we human interact with. And a lot of water exists in frozen form. We are going to talk about that later. And a lot of water vapors exist in the atmosphere and drive the change of weathers. So if you think about water, it's like everywhere. And you can see all the 3 forms sometime in some of the season or some of the places of the world. That is fantastic. And water is polar. So it's a universal solvent. Water almost solves everything. Not everything, but most of the things, right? Even water cannot solve rocks or metals, but it can gradually change the physical and the chemical properties of the metals and the rocks. Think about it. And because water is polar and they stick to each other, it takes a lot of energy to break apart the molecules. So water can absorb enormous amount of heat, and it can store enormous amount of heat. That's why when people live close to the ocean, they experiencing milder climate change. That is because the properties of the water. Hydrologic cycle. So there's 2 things I need to emphasize here. One is evapotranspiration. The other one is evaporation. These 2 are different. Evaporation is this simple process. Water becomes from liquid to gas. That's evaporation. And evapotranspiration, that means the plants absorb the water and then breathe the water out of them. And that is a very powerful, very strong process. You are going to learn about this in the one of the Annenberg lessons. And another significant process in this cycle is precipitation. It's raining, snowing, hails, right? Raining like ice, sleet. So those are the precipitation. Remember, the sun drives this cycle. The sun gives the energy to drive the evaporation, evapotranspiration, and then precipitation. Without sun, these 2 or 3 significant processes would not happen. And our water is locked into this hydrologic cycle. Every single molecule of water. So some quick concept here. Runoff, that is the surface water that move across the surface of the land and enter streams and the rivers, or oceans or ponds. So that means the surface water is moving on the surface of the planet, of the land. Mainly we are talking about land here, and enter a larger body of water. And the groundwater is water that fills space in the substrate. This is interesting. We're talking about substrate. What is this substrate? It's a mixture of gravel, sand, rocks. So I want you to think about aquifer. Aquifer is not a flowing river. Well, although it moves like that. But the aquifer is a substrate absorbing the water underground. So that's the first time we talk about groundwater and aquifer. We're going to peel this onion. Okay, we're going to peel this onion of groundwater. That's the first layer I want you to peel. Now, the global water cycle. So I already go over the hydrologic cycle, and now I want to mention this concept of residence time. So if water is moving, if we look at this part, it has a shorter residence time. For example, let me see, over here, if it's in the surface of the soil, the residence time is 1 to 2 months. And living organism, a few hours to days, right? When we drink in the water flow in our body and eventually go out. For human, it's pretty fast, but for some animals or plants, it's probably slower, especially in winter when they're hibernating. That's why we say a few hours to days. And the freshwater bodies, about from several months to 10 years. So this is a shorter residence time. If we look at the ocean, the water can be in the ocean for thousands of years, and if it's in the groundwater, some part of the groundwater, it can linger about like 10,000 years. I don't see a number in the glaciers, in the frozen world, that is even longer than 10,000 years. Some of the water probably exists there for millions of years, I suspect. Where is water? So majority of the water on the planet is salty. Okay, you can see the number here. About 97% is salt water. And a very little fraction of this pie, let me see. I can't, okay, here we go. Majority of the pie is ocean. And a small fraction is other salt water and fresh water. So fresh water, remember this, I test this every year, 2.5% of the entire water available on the planet is fresh water. That means we can potentially use it. Okay, some people extract ocean water and get rid of the salt. That's another story. But mainly we're using the fresh water here. It's 2.5% of the entire water on the planet. If you think we have a lot of water we can waste, we don't have to cherish, that is wrong. So in this 2.5% of fresh water, majority is frozen. That's why we're going to talk about the cryosphere. And about 30% is groundwater. And a little bit other fresh water is the rivers and the ponds we see. And also the swamps and the wetlands and some of the water in the living organism that it's hard for us to see. And also it's hard for us to see the water in the soil and the atmosphere. So remember the bigger numbers, okay? Bigger number here is salt water, and in the fresh water, majority is frozen, and then 30% is groundwater, and the running water we see that is in a very small portion of the fresh water.